Okay, so today we're going over variation of parameters. So variation of parameters is another way to find a particular solution. As compared to the method of undetermined coefficients, this method is a bit stronger in the fact that if your particular, or if your non-homogeneous portion of the problem contains a portion of the homogeneous differential equation, it'll compensate for that. Okay? So, with variation of parameters, okay, we have y, which equals y sub c plus y sub p. Okay? And then we're going to look for the particular solution. Looking for the complementary solution is the same using the auxiliary equation. But if we want to find the particular solution, okay, so let's start off with this. Y sub c equals c1 y1 plus c2 y2. Okay? And y sub p is going to equal u1 y1 plus u2 y2. Okay? So particular solution is what we're going to be looking for. Where u1, that's u1 prime, is going to equal now w1 divided by w, and u2 prime is going to equal w2 divided by w. Okay. Now w is going to, I'm going to use just solid lines and not write determinant. Okay? So this is going to be y1, y1 prime, y2, and y2 prime. And w1 will equal now 0, f of x, y2, y2 prime, and w2 is going to equal y1, y1 prime, 0, f of x. Okay? And it should be noticed where f of x is the non-homogeneous part. Okay? Now, this might seem pretty complicated, but it's actually, it's a procedure. A procedure that's, once you follow the rules, and normally whenever students are taking the test in class and they have a note card, I allow them to put these formulas on the note card. And so as long as you have these formulas on the note card, then it's not too difficult for the procedure. Okay? So why don't we just go ahead and start with an example before we go to the next video. Okay. Okay. So let's say we have y prime prime plus y is going to equal secant of x. Okay, like on all these problems, the very first thing you have to do is you have to consider, all right, I have to find the homogeneous portion of the problem. So we have the auxiliary equation that m squared plus 1 is going to equal 0, or that m squared equals -1, and we take the square root, m equals plus or minus I. Okay. All right, now remember, whenever you get into the complex domain, you're getting into sine and cosines because of Euler's formula. So y sub c is going to equal c1 So this right here, this is C1 Y1 plus C2 Y2. So cosine and sine are my Y1 and my Y2. So now we have to figure out what W, W1, and W2 are, and then from W, W1, and W2, we're going to find U1 and U2, and then we're going to integrate U1 and U2. I mean, we'll find the derivative of U1 and U2, and then we'll integrate those to get the U1 and U2 for the problem. So let's look at W first. Now remember, this is Y1, Y1 prime, Y2, Y2 prime. Okay, so Y1 is cosine of x, and then derivative of cosine is negative sine of x. And then we have Y2 is sine of x, and the derivative of sine is cosine of x. Okay, so that would equal cosine squared x, and then plus sine squared x, and that ends up coming out to be 1. Okay, now W1. Okay, now let's look back at the beginning of our problem. The right-hand side of the problem is that secant of x. That's the non-homogeneous portion of the problem. Okay, so remember that W1, which is going to be 0, then f of x, and Y2 prime is going to equal, so that's 0, that's secant of x, now that's sine of x, and derivative of sine is cosine. So 0 times cosine is just 0. So this is going to equal 0. Now minus okay. So that's a negative sine times secant. But remember that secant of x is 1 divided by cosine. So what does this really come out to? Comes out to negative tangent of x. Okay, great. We found W1. Now W2, which is going to equal, this is Y1 prime, 0, and f of x. Right. So this is going to equal determinant. So Y1 was cosine of x. Derivative of cosine is negative sine of x. This is 0. This is secant of x. Okay. So that's cosine of x times secant of x minus 0. But remember that secant of x is just 1 divided by cosine, so this is really cosine divided by cosine, so that just becomes a 1. Okay? So, let's remember that U1 prime is going to equal W1 divided by W. Okay? So that's going to be, where's my W1? Negative tangent of x divided by 1, which is just negative tangent of x. Okay? So if I want to find u1, I'm going to have to, you know what, let's go ahead and find u2 first. So u2 prime would be w2 divided by w. In this case would be 1 divided by 1, which just equals 1. Okay, so w1, w2, and w tell us what u1 and u2 prime are. Okay. Okay, now that we've got the primes, we need to integrate this thing to get u1 and u2. All right? So, u1 would equal the integral of negative tangent of x with respect to x. Now, on this type of integral, we're not going to put a plus c on there because we don't care about the plus c. What we're really looking for in this case is the function that we're looking for, okay? The function u1. I mean, because there's already plus c's all over the problem. So, if I integrate tangent, the integral of tangent is the natural log of secant. So, this is going to equal the negative natural log of secant of x, okay? Now, u2 would just equal the integral of 1 with respect to x. So this just becomes x. Okay. Now, remember that y is going to equal c1, y1, c2, y2, u1, y1, u2, y2. I might have to do this in 2 lines. Okay. So this is going to equal c1, y1 was cosine of x, plus c2, y2 is sine of x. Okay? And then u1 is right up there, so that's minus the natural log of secant of x times cosine of x. Okay, I'm going to run out of room, so I'm just going to write this plus u2, which is x, and then y2 is sine of x. And so that thing, well, I'll mark through it. That thing right there, that is the ultimate solution to our problem.